Hello, everybody. I hope everybody enjoyed a beautiful weekend. It was absolutely gorgeous outside. I spent some time this weekend on my kayak on Lake Lilanona. It was beautiful out there. I got a lot of yard work done, which is why this video is coming to you at about 11:30 on a Sunday night. This video, we are going to take a look at the college prep waves and vibrations homework problems 6 through 10, and most of these problems are going to deal with pendulums. So let's get started with problem number 6. What is the period on Earth of a pendulum with a length of 1.0 meters? So we're given the length of the pendulum of 1 meter, and we're being asked for the period. And remember, our symbol for period is the capital T. I know that my pendulum formula is T equals 2 pi times the square root of L over G, the length divided by the gravitational acceleration. And because I know that we are on the Earth, that my value for G is going to be 9.8 meters per second squared. So I plug that along with the length into my equation, and I am going to get a period of 2.0 seconds. One quick note about pendulums. We're always going to assume our pendulums are on Earth unless we state otherwise. So we might not explicitly say it's on Earth, but we can just assume that unless I tell you differently, because most of the pendulums I know are on Earth. There you have it. Problem 7. How long must the pendulum be on the moon where G equals 1.6 meters per second squared in order to have a period of 2 seconds? All right, now I know of a pendulum that isn't on the Earth. I really should read through these problems before I start yapping away. Let's take a look and see what we're given. We are given the gravitational acceleration of the moon, which is 1.6 meters per second squared. I don't even know why you would bring a pendulum to the moon. I mean, again, what do you bring to the moon except for a big spacesuit and I don't know what else. Oh, let's move on. The period of my pendulum is 2 seconds, and we want to know the length, so we have to solve for L. Once again, we are going to start with our pendulum formula. T equals 2 pi times the square root of L over G. In this case, we are solving for the length, so we have to rearrange our formula to solve for length. It's kind of tricky to solve for L in these problems because it's inside the radical, and we'll talk about that in just a moment. But to solve for length, we end up with length equals T squared times G divided by 4 pi squared. We plug our known values into that equation, and we are going to get a length for the pendulum of 0.16 meters. One quick note when we are solving for length, and if I'm in a particularly bad mood, I might have you solve for the gravitational acceleration at some point as well. But when you want to solve for either the length or the gravitational acceleration, you're going to need to get them outside of the radical, or you're going to have to need to remove the radical in order to solve for one of those. And you do that by squaring everything. So you would square everything in the problem. And when you square this, the radical will go away. The one thing you have to keep in mind, though, is that when you square everything, you also have to square the 2 pi, and you have to square both the number 2 and pi. And when you do that, you'll get 4 pi squared. One of the most common mistakes people make in these problems is that when they square 2 pi here, they end up with 2 pi squared. They forget to square the 2. And you don't have 2 pi squared, it has to be 4 pi squared. So just be careful of that when you're solving these problems. Can you tell I got a little bit too much sun this weekend? I definitely probably got a little bit of heat stroke going on here. Let's take a look at problem number 8. Thank goodness this is going to be a short video. On a planet with an unknown value of G, the period of a 0.75 meter long pendulum is 1.8 seconds. What is G for this planet? So we are given the length of the pendulum, 0.75 meters. We are given the period of the pendulum, 1.8 seconds. We are looking for the gravitational acceleration of this planet. Once again, we're going to use our pendulum formula, this time solving for g. And when I do that, I will have g equals 4 pi squared times the length divided by t squared. Plug in my known values to that equation, and I am going to get a value of g, or gravitational acceleration, of 9.1 meters per second squared. Problem 9. How long must a pendulum be to have a period of 2.3 seconds on the moon, where my gravitational acceleration is 1.6 meters per second squared? So in this problem, we are given the gravitational acceleration of the moon, 1.6 meters per second squared. We are given the period, 2.3 seconds, and we are being asked to find the length of the pendulum. So we are going to solve this one for length, starting with our pendulum formula. We're going to rearrange it and solve for length, just like we did in problem number 7. And we are going to end up with L equals t squared times g divided by 4 pi squared. I plug in my period and my gravitational acceleration, and that will give me a length of the pendulum of 0.21 meters. Problem 10, ending on a pretty easy problem here. What is the period of a pendulum with a length of 1.4 meters? We're given the length of the pendulum, 1.4 meters, and we are being asked to find the period. So when we use our pendulum formula, we don't need to do any rearranging. We're already solved for period. T equals 2 pi times the square root of L over G. I plug in my length and my gravitational acceleration, again, assuming that it is on Earth, and that is going to give me a period for this pendulum of 2.4 seconds.